Okay, so this is a little review of what we studied in that first section 1.1 in Unit B, the energy flow in technological systems. Okay, start with an idea of motion. You can see uniform motion is a term. It refers to any object traveling at constant velocity. That means traveling at the same speed in a straight line. When we talk about the position of an object, that means where it's located. So it's a distance that an object is relative to some frame or point of reference. Like when I'm golfing and I'm 200 yards from the pin, right? We know that that is a distance, right? The ball is relative to the pin where we want the ball to go. Speed, we call it a rate which an object moves. So an object is moving, given distance and a given amount of time. If the position distance of an object changes, then it must be in motion. Okay? That's how you can tell. All right, when we want to calculate average speed, there's a formula for it. You take the total distance divided by the total time. Now, the formula that we use is here. Okay? It's kind of similar to that in your data booklet. You can take a look at it, and here's a few examples. Let's try using the formula. Remember, we talked about this idea of a triangle for the formula. And the triangle looks like this. You've got distance on the top, you have speed, or delta D, and time. Now what you can do is you can cover one of them, and then you can figure out the relationship between the other two. Cover the one you're looking for. So in the first example here, 300 kilometers, 2.5 hours, what's the average speed? So I hide this right here, the speed, hide that, and then you end up with d over t. And so in the case of the calculation, you write down what you have here, delta d over delta t every time. Write down your formula. You got 300 kilometers, and you have 2.5 hours. You want to make sure you state your units at the end of this in kilometers per hour. So I take the 300, and I divide it by 2.5, and end up with 120 kilometers per hour. Now, we like to do things in significant digits in scientific notation, and so the idea of 1.2 times 10 to the second kilometers per hour is generally the preferred answer, okay? All right, here's another example for you. We're looking at the Usain Bolt. Set a new world record by running 100 meters in a time of 9.58 seconds. Beating the old world record. What was his average speed? Well, speed, delta D over delta T, put in your 100 meter dash here, over 9.58 seconds. Get your calculator out. Here we're going to want 3 significant digits at the end of it. So 100 divided by 9.58. And I get 10.4 meters per second is the unit here. Okay? That gives you a couple of good examples to look at, and then we'll take a look at what's happening next in a moment.